Hello friends, continuing with the topic of electric potential, today we take up electric potential difference between 2 points in an electric field. So today's topic is electric potential difference between 2 points in an electric field. So first we define what is electric potential difference between 2 points in an electric field. So here is the definition. Work done in bringing a test charge Q0 from one point to the other in an electric field against repulsive forces is defined as electric potential difference between 2 points in an electric field. I repeat, work done in bringing a test charge Q0 from one point to the other in an electric field against repulsive forces is defined as electric potential difference between 2 points in an electric field. You look at the diagram. So here is any charge plus Q lying in any region of space. As a red color shows the plus Q, and a test charge Q0 is at point A at any instant of time. It experiences a force F which is directed away from point A and plus Q, and this test charge Q0 is brought to point B against a repulsive force, and whatever is the work done, that work done is called as electric potential difference between point A and B. And now mathematical expression. A. Physical situation. Consider a point electric charge plus Q lying in any region of space. Let A and B be the 2 points in the electric field of charge plus Q at a distance RA and RB respectively, as shown in diagram. So this is the physical situation. B. Electric potential at point A, say VA, that is equal to K0 Q by RA. Let us mark it as equation 1. C. Electric potential at B, say VB, is equal to K0 Q by RB. Let us mark it as equation 2. Now since RB is less than RA, you can look at diagram and verify it. RB is less than RA, therefore VB is more than VA. Hence, potential difference between points A and B, say VB minus VA, is equal to K0 Q by RB minus K0 Q by RA. Or we can write it as K0 Q into 1 by RB minus 1 by RA. Or it can be expressed as VB minus VA is equal to K0 Q into 1 by RB minus 1 by RA. Let us mark it as equation 3. Now equation 3 gives the expression for electrical potential difference between 2 points A and B in the electric field of charge plus Q. Now you can see in the diagram where is point A, where is point B. So equation 3 gives the electric potential difference between points A and B. The alternative definition of electric potential difference. Line integral of electric field between 2 points in an electric field is also defined as an electric potential difference between 2 points in an electric field. I repeat, line integral of electric field between 2 points in an electric field is also defined as an electric potential difference between 2 points in an electric field. Okay, so mathematical expression, how we write: Vb minus Va is equal to integration a to b E dot dr, or it is equal to integration a to b E dr cos theta, or it is equal to integration a to b E dr cos pi. Now the theta between E and dr is pi. How it is pi? Let us see in the diagram. So the direction of E and F is same here, and the direction of dr is opposite to electric field. So the angle between E and dr is pi. Okay, so we write Vb minus Va is equal to integration a to b E dr cos pi. So theta is replaced by pi, but cos pi is minus 1. So we write Vb minus Va is equal to minus a to b integration a to b E into dr. Let us mark it as equation 4. But electric field at any point C, this is point C, at a distance r, from the charge plus q is E is equal to k naught q by r square. Already we know this, that is the electric field intensity due to a point charge at a distance r from it is given by the expression E is equal to k naught q by r square. Therefore Vb minus Va is equal to minus a to b k naught q by r square into dr. We replaced E by k naught q by r square, or it is equal to minus k naught q integration a to b dr by r square, or it is equal to minus k naught q integration a to b r power minus 2 dr. Now we evaluate the integrals, or it can be written as equal to minus k naught q bracket start r minus 2 r raised to power minus 2 plus 1 divided by minus 1 bracket closed limits a to b, or it is equal to minus k naught q into 1 minus 1 by r limits a to b, or it is equal to k naught q into 1 by r limits a to b, or it is equal to k naught q into 1 by rb minus 1 by ra. We evaluate the limits, upper limit minus lower limit. So we replace r by upper limit, then minus the lower limit. So we write k naught q into 1 by rb minus 1 by ra, or we can write Vb minus Va is equal to k naught q 1 by rb minus 1 by ra. Let us mark it as equation number 4. The equation 4 is same as equation 3 above. So this shows that line integral of electric field between 2 points in an electric field is also defined as electric potential difference. Okay, this is the alternative definition. Either we say work done or we say line integral. Okay. Now SI unit. SI unit is volt. So whether it is electric potential or it is electric potential difference, the units are same, because difference is of the same physical quantity has the same units. Okay. So SI unit is volt, being the electric potential difference of two similar quantities. Now electron volt, it is another unit of energy. Let us have its definition first. Work done in bringing an electron through a potential difference of 1 volt in an electric field in a direction opposite to the field is defined as an electron volt. I repeat, work done in bringing an electron through a potential difference of 1 volt in an electric field in a direction opposite to the field is defined as an electron volt. Now, relationship between electron volt and joule. So when we write 1 eV, for E we write 1.6 into 10 raised to power minus 19 coulomb, and for V we put 1 volt. So it becomes equal to 1.6 into 10 raised to power minus 19 coulomb volt, or it can be written as equal to 1.6 into 10 raised to power minus 19 joules. So 1 coulomb volt equal to joule. And now proof. We know that VA is equal to WA by Q naught and VB is equal to WB by Q naught, and is the work done in bringing a test charge from point A to point B in the electric field. Therefore, VB minus VA can be expressed as equal to WB by Q naught minus WA by Q naught, or it is equal to 1 by Q naught into WB minus WA, or we can write it as WAB divided by Q naught, or WAB is equal to Q naught into VB minus VA. So work done in bringing an electron from one point to the other through a potential difference of 1 volt is defined as electron volt. Now let us consider the expression WAB is equal to Q naught into VB minus VA. When Q naught is equal to 1E, that is equal to 1.6 into 10 raised to power minus 19 coulomb, and VB minus VA is 1 volt, then WAB is equal to 1E into 1V, and it is equal to 1 electron volt, or WAB is equal to 1 EV. We can write it as equal to 1.6 into 10 raised to power minus 19 coulomb into 1 volt, or it is equal to 1.6 into 10 raised to power minus 19 coulomb volt, or we can write it as equal to 1.6 into 10 raised to power minus 19 joule. So you remember the relation 1 electron volt is equal to 1.6 into 10 raised to power minus 19 joules. So it is how we can convert electron volt into joules. So you remember this scale. This scale is very important for doing numericals. Okay. Since SI unit is joule and energy is sometimes given in electron volts, you have to convert it into joules. So using this scale, you can convert electron volts into joules. And now assignment 2.1 continued. Question number 16. A point charge Q is placed at point O as shown in diagram. Is Vp minus Vq positive or negative when number 1 Q is more than 0 and number 2 Q is less than 0? So you find out the answer to this question and solve it. Now the assignment 2.1 continued. Question number 17. The two graphs drawn below show the variation of electric potential V with 1 by R being distance of the field point from the point charge. For the 2 point charges Q1 and Q2, number 1, what are the signs of the charges? Number 2, which of the two charges has a larger magnitude and why? So you find out the answer to this question also on the basis of the text that you have learnt. Now question number 18. A point charge moves from point P to point S along path PQRS in a uniform electric field E. pointing parallel to positive direction of x-axis. The coordinates of points P, Q, R, S are A, B, 0, 2A, 0, 0, AB, 0 and 0, 0, 0 respectively. Calculate the work done by the field in the process. So answer would be minus QA into E. Assignment 2.1 continued. Question number 19. A test charge Q is moved without acceleration from point A to C along the path A to B and then from B to C in electric field E as shown in the figure. Number 1. Calculate the potential difference between A and C. Number 2. At which point of the two is the electric potential more and why? Okay. You crack these numerical problems on the basis of the text that you have learned. And thank you so much. God bless you. With this we finish with the topic of electric potential. Next time we'll start with the topic of equipotential surfaces. Till then, goodbye.